I worked with NASA. I worked for MIT's Lincoln Laboratory. I was a lead radar engineer.
How do you think about investing in space?
So for every dollar you're investing in space, you're not investing in Nvidia. You're not investing in Microsoft. I don't think the next thing is space. I think there are many jumps between where we are today and space being the next thing.
We have a community at Potential Multibaggers, and I said on the community, guys, this is not a fad. This is really the breakthrough moment. Did you have the same feeling?
When Nvidia started rallying, basically what happened is everyone was Googling Nvidia stock and my videos would come up as the answer, right? And so that's how I got big on YouTube. My wallet and my view count rose at the same time. It was really interesting. So I need your intervention because you're my boss. I'm the AI, you're the human. You're gonna tell me, right? I'm gonna read all your email and I'll tell you when there's one that, hey, I have no idea how to respond to this. That'll get kicked to you. Smart glasses become the next big thing that'll interface with your phone to deliver this AI hands-free experience.
Welcome to Multibagger Nuggets, where we talk about investing in stocks. Your host, Chris Hendricks, from Multibagger Nuggets, also known as From Growth to Value, invites you to join this podcast at multibaggernuggets.com, where you get much more content, both free and paid. Today, a special guest is joining us again, Alex from the YouTube investing channel, ticker symbol U. Alex has over 350,000 subscribers and several of his videos have gone above 1 million views. As you'll hear, Alex is very knowledgeable about AI and everything surrounding it. Let's dive into this great conversation with a YouTuber, an engineer, and a great investor. Here's Multibagger Nuggets, where you hear about tomorrow's winners today.
All right. Hello, Alex. I'm going to introduce you first. So you're Alex from ticker symbol U, a big YouTube channel about investing, 355,000 plus subscribers. Yes, multiple videos with more than 1 million views. And you're, can I say that, specialized in AI? If you would have done the intro instead of me, what would you have added?
I think that's pretty good. My name is Alex. My background is in electrical engineering and math. Before I was a full-time investor, I was a rocket scientist at MIT for about 8 years. I focused a lot on visual data and radar data and combining those two things to do some pretty interesting things for the government. Then I became a full-time investor and I decided to use my technology background to get an edge on the market. My edge is just sort of understanding the technologies in the products and services that are moving society forward. So I tend to focus on technology stocks, and lately that's turned into AI, software, and hardware. And that's just because that was my background, both in academia and at MIT. And now that's what I do full time. I invest and I talk about it.
We talked already before. I thought you had a great backstory. You already mentioned it very short. But can you elaborate a little bit? So most people will be interested there, I think.
I worked with NASA. I worked for MIT's Lincoln Laboratory. That's MIT's big government lab. It's actually physically separate from MIT campus, but it's part of MIT proper. So what I did there was I was a lead radar engineer on a radar that was on the ground and it looked up into the sky. And it did a few different things. It did weather modeling, simulation, and analysis for rocket launches and missile tests. It also was the beacon tracker for those things. So if you've ever seen SpaceX launch a rocket or NASA launch a rocket, those things have beacons on them. And what they do is they talk and they say, here's where I am, here's what time I think it is, here's my altitude, here's how fast I'm going. And so radars will receive that data so that they don't have to figure it out themselves. One computer talking to another. There were other things that I did related to those radars, looking up into the night sky to look at certain things in the sky, certain man-made objects, as well as support other radars, a range of radars. So I lived overseas in the Marshall Islands for 4 years at the Ronald Reagan Ballistic Missile Defense Site, which is a big mouthful. But basically what happens is there's all sorts of different radars in the middle of the Pacific Ocean. That's where I was the lead on one of them. And the special thing about these radars is they all work together to achieve pretty tough missions. Sometimes that's a NASA rocket launch. Sometimes that's a ballistic missile test going from California into the Pacific Ocean. And what happens is we have some radars, they have a very big beam at very low resolutions. And we have other radars and telescopes that have very narrow beams at very high resolutions. And what the big beam radars do is they help find an object in the sky, then pass that information to a radar with a smaller beam that then passes that information, so on and so forth, So the big radars are what we call search radars. The smallest radars are what we call tracking radars. And they work together to make sure that the tracking radars can pick up objects that are moving really, really fast, really, really far away in time to track them before they land, whether that means a rocket launch or a missile test. So that's like the 2-minute overview. I could talk about this for hours. It was 8 years of my life, but that plus telescopes, which, instead of using radio waves, they use light. That's what I worked on, is the handoffs between radars and telescopes.
Before we go on to anything else, how do you think about investing in space? Because there are, some pretty interesting companies out there, and others, like SpaceX, of course, are still private, but you can get in if you know how to do that as a private
Yep.
investor. So how do you think about that?
Right now, I think space is obviously in its very, very infancy, right? So the way I play space right now is sort of twofold. If I'm thinking about like infrastructure in space, that's a very, very long-term bet, right? Amazon is actually one of the leaders in this area, believe it or not. Jeff Bezos has a lot of like pet projects that involve space, not just Blue Origin. He's been talking a lot about developing the infrastructure, the internet and sort of the digital transmission infrastructure to handle things in space. So I'd be looking at those things as very, very long-term investments. And then nearer term, I think it's just space beneficiaries, right? So when you think about Starlink providing the internet to the entire surface of the Earth, or one day the entire surface of Mars, who benefits the most from that? For example, Netflix is an obvious beneficiary. The more people with internet, the more likely they are to sign up for streaming services. Same with Google and YouTube. The more people that have internet, the more likely it is that they'll use these services. So that's a more near-term benefit. I tend not to think about space too much in terms of investing, not because that's a bad investment, but because it comes with a high opportunity cost. So for every dollar you're investing in space, you're not investing in Nvidia. You're not investing in Microsoft. So like I tend to think about the more near-term winners, and then as the landscape changes, I'll move to the next thing, right? So right now my focus is on artificial intelligence software and hardware. And if they benefit from space, that's sort of just like a nice value add, but not something I really think about in my investment thesis, if that makes sense.
All right. So actually, if I understand you well, then you went from space to AI. You might go back when that's the next step, right?
My guess is there's many jumps between where we are today in terms of AI and the software, the products and services that it empowers, and having space be at the forefront of the conversation. Like, I don't think that the current thing is AI. I don't think the next thing is space. I think there are many jumps between where we are today and space being the next thing.
So how did you go from space to AI then? What was the evolution there?
Sure. So actually, when I was working on these space programs, I was the guy helping them leverage AI. So my job on these space programs was to train neural networks to understand, to separate relevant detections of these radars from things that could be just noise. We've been using AI at MIT for well over a decade. This is like not new news to us. Generative AI is new. That's a new thing, the transformer models and all these large language models and all the things people are excited about today. But 10 years ago, we were using neural networks to solve all sorts of advanced technology problems, like helping a radar understand when it has detected something and when what it thought it detected turns out to just be noise. It was a very natural transition. My bachelor's degree is in electrical engineering, but my master's degrees are all in sort of AI for electrical engineering. They're in systems optimization, which is most AI functions that are not generative AI functions are focused on minimizing or maximizing something by doing some sort of prediction and modeling. So my background is in traditional AI, not generative AI.
Yep. Makes sense. I remember actually when ChatGPT came out and I first tried it like 2-3 days. We have a community at Potential Multibaggers. And I said on the community, guys, this is not a fad. This is really the breakthrough moment. Did you have the same feeling?
Instantly. And so like OpenAI's GPT has been around for a while before ChatGPT, but Google actually wrote the original paper on transformers, right? So Google has also been using transformers for long before ChatGPT came out. So by the time it came out, I kind of had already known a lot about it. What was interesting about it was understanding that, hey, it can actually do this inference step. you give it a tiny piece of text, a sentence, a couple sentences, a paragraph. That's actually very tiny compared to how much GPT can ingest, and we're kind of seeing that now. But how fast it can reply and give a human-like response, that was kind of new. That was like the aha moment. Like, hey, there's actually a few different killer apps for this transformer technology, not just adding context to people's searches and things like that. So yeah, as soon as I heard about GPT, I knew that was something special. And then as soon as ChatGPT came out, I realized it was like even more special than we could have imagined, right? And we're, 18 months later, it's still dominating the news cycles today. So,
Oh yeah, sure. And also what I thought was special, like, I was there when the internet came up, and my father
yep,
was very,
me too.
very, very interested in the internet, and we had internet in 1995 already. Very slow. It took like an hour to download one picture, a crappy
I
picture.
remember, yeah.
So, but at that moment, internet was for geeks, right? But
Yeah.
what you see with ChatGPT right now is that immediate with ChatGPT, then the general release to the public, like ChatGPT 3, it was, I think, an instant success with consumers. And I think that makes a difference. Do you agree, or do you think there are more nuances to this?
Totally. No, I think that's a really great call out. So the internet was pretty fast to be adopted given how little infrastructure we had, right? The first internet ran on phone lines, right? Dial up was literally like you would have to tell somebody to get off the phone so that you could use the internet. I remember that, you
Oh
know?
yeah, I remember as well, because when I was three-quarters into that picture downloading for an
Yeah,
hour,
somebody
my
would
mom,
pick up the phone. Yeah,
yeah,
exactly.
I had to
Exactly.
start over.
Or you'd be playing like one of two online games and then somebody would pick up the phone and it would just like ruin everything.
Or
Yeah.
like, Chris, go offline. I have to make that call. Okay, mom.
Exactly. Exactly. Yeah. So the internet is like the backbone infrastructure, right? Even before that, personal computers were a thing. So before I had internet, I already had a personal computer. My mom had one for her office. Your friend had one, stuff like that, right? Then the internet came and connected them together so they could talk. And for a while, it was real slow. And then every piece of that got faster and faster. Both the internet, right? Modems, routers, switches, the cables themselves, the protocols, but also the computers were still getting better and better themselves. More RAM, better processors, better graphics processing, right? Nvidia created this thing called the graphics processor, a totally separate chip to do it. Those two things kept going in parallel. And then we got this third thing, the mobile internet, right? So like this is actually a computer. People like, we call it smartphones, we call it something else, but it's important to understand that mobile phones are actually mobile computers. So there's like this trade, right? You can have a computer that's big and incredibly powerful, or you can have a computer that's small, a lot less powerful, but fitting into the same form. It's fitting into a form factor that can go in your pocket, right? And there's obviously a whole spectrum: desktops, laptops, tablets, phones, right? We're seeing these new AI devices that are like half the size of a phone, the Rabbit R1, the Humane AI pin, things like that, right? So now there's these sort of three pillars working in parallel: computers and computing, the wired internet, and the wireless internet, right? And to make that magic happen, there's this fourth piece, which is servers in the cloud that your edge devices talk to do things like interface with ChatGPT. You send it right now, you send your query right now to the cloud. The cloud does some inference, right? It returns back the answer. If you watched Google I/O on Tuesday or OpenAI's GPT 4o release on Monday, you now saw that some of that was either running on device or they had some magic tricks to make it like super low latency between the device and the cloud, right? The reason I said all that, the PCs, the internet, and the phone, is because now there's a fourth thing. There's this layer on top of all of them we're calling generative AI. And what generative AI is doing is it's sort of going back and removing the friction of the other three things, right? So it's more than just automation. It's sort of cognition. I don't really have like a better word than that right now, but it's some form of basic understanding of context and of structure of information. So you can say something like, hey, order me an Uber from point A to point B, and it will understand all of the nuances of that statement beyond what you just said. Hey, Uber is an app. It's a ride sharing app. This costs money. I need to pay for it, right? There's like a lot of things that we take for granted when we communicate that now these AI models are starting to understand as well. I think when we talk about the adoption of ChatGPT and how it hit like 100 million users in something like 2 months, it was completely crazy. It's because all of the infrastructure was already there. The mobile internet, high speed, regular internet, wired and wireless, mobile devices, personal computers, and all that, so that 100 million people could instantly have it, right? The distribution was there to play with it. Does that make sense? So, like,
Oh yeah, totally.
you kind of have to, like, you can't just say generative AI. Generative AI actually sits on top of all the other technology that, like, humanity has ever built, right? So,
Yep. It's also interesting to see that when ChatGPT came out, I said, this is the 1995 moment for large language models. That will actually be my next question. What you thought about the releases of Google and ChatGPT? I'm actually surprised by how fast things are moving. I thought that it would have taken longer to see where we are now because we are already like 18 months in and we're already like in the year 2002 maybe. Do you agree? And what, can you combine that with the releases that we saw this week?
yeah. So, first of all, I do agree. And I think that goes back to what we were sort of saying before. Every major general purpose technology is going to evolve faster than the last because it's leveraging all the advancements of the things that came before it, right? So, back to the internet example, the reason that the mobile internet evolved so much faster than the first version of the internet is because people were running into problems that were already solved, right? So, computing was already getting smaller and smaller, small enough to make the smartphone, but also small enough to put way more power into desktops, laptops, and smartphones to enable things like app stores, things like real-time video communication, even over wireless, right? For a long time, you couldn't have like a video Zoom call like this over wireless internet. It just wasn't good enough, right? Remember 2G and 3G, right? It's like, but if you were wired and you had DSL or a cable or whatever, all of a sudden you could do things in real time, video to video. AI is sort of doing that same thing, but it's standing on the shoulders of all those different giants. Computing is getting way, way better, way, way faster, right? Both at the server level, that's NVIDIA's chips, at the inference level, whether we're talking about Apple's M3 or 4 chips, depending on what phone you have, or, Microsoft's chips, Intel's chips, whoever's making them, depending on your handset, right? Whatever. And that is part of the story here. So going back to your other question, OpenAI and Google, I'm still like mulling it over. I actually tried to make like a reaction video on this that was supposed to come out today. And it was so fuzzy and vague that I was just like, I kind of need to go back to the drawing board. So what I think is happening, there's two different things happening. So first is models are getting more intelligent, right? Which right now means higher and higher parameters, which is just a number, the number of nodes in their neural network is going up. But one day things will get better without the models getting bigger, right? So Meta Platforms is working on making models more efficient per parameter instead of making the biggest parameter model they can, right? Because they want things to work right on the device. And for things to work on a device, it needs to be like a much smaller model than something that's running in a data center. Going back to Google versus OpenAI, I think OpenAI is playing what I think of as an infinite game. If you've ever read Simon Sinek's Infinite Game or watched his TED Talk on it, he talks about two different types of companies. One type that are playing the infinite game, like Apple, are just focused on serving their customers as well as they can. They're like, what does the future look like? How do we build it? And what does that give our customers, right? The other kind of company is playing the finite game. They are looking at their competitors and they're saying, what are they doing? We got to do that too. We want a piece of this market. So infinite players look forward, finite players look at at their competitors. Why am I saying that? Because OpenAI is playing the infinite game. What they're trying to do is just build the best models they can to be as useful as possible. What we saw with GPT-4o, the model is actually not much better than GPT-4 Turbo. It benchmarks a little better, but where it really shines is it can do GPT-4 Turbo level recognition, understanding across text, video, and audio. So it's this truly multimodal, all-in-one, not stitched together model that can really understand its inputs, video, audio, and text. And there are a lot of uses for that. Sam Altman was on the All In podcast 8 days ago, 9 days ago, whatever. And he was talking about how there's like two camps in AI. One is I want to gain more leverage as myself. The other is I want a badass personal assistant, right? I want an executive assistant that understands me, but is separate from me. I think OpenAI is taking the latter approach. They want to make the ultimate badass personal assistant, right? You talk to it, it can get you information, it can craft you essays, it can do the mechanics of all the things that you don't want to do. That was long-winded, but that's because Google, I think, is actually doing the other thing. I don't think Gemini is going to be a good personal assistant at all. They showed off Project Astra, which maybe is their attempt at doing the personal assistant thing. But other than that, a lot of what they showed off at Google I/O was more about using AI to like turn all of their existing services up to 11, right? Hey, you want to plan a vacation? Here's this entire workflow that stitches together Google Search, Google Maps, Google Sheets, like all these different parts. So you just say some things, you give it some parameters, and it's generating like sort of all of these different artifacts for you instead of you manually having to do them. OpenAI is more about an executive assistant, and Google seems to be more about giving the actual user more leverage via all these products and services. So I'll stop there because that's a lot. We can dive into the nuances and stuff, but like that's my fuzzy feeling on the two actually being much more different than people realize.
Yeah, I really like that. And I also had to think about the personalization, which I feel that ChatGPT also puts much more emphasis on a personalization compared to Google and Gemini. Do you agree?
Yeah, but I think that's mostly because of like those two different paradigms, right? So OpenAI, one of the things that a really great executive assistant needs to know is just all about you, right? Hey, you like this versus that. For example, I'm a first generation American. My mom has a heavy Russian accent. So the way she likes to ingest information is very different than the way I do. She needs people to speak slowly. She pays a lot of attention to their body language. I can listen to a podcast at like 2 times speed. My mom can't do that, right? Understanding those nuances is an important part of that executive assistant role, right? There's the information, but then there's also how you want it, like how to best convey it to you. So OpenAI definitely with GPT-4o, you can just tell it, hey, speak slower. Hey, speak faster. You can interrupt it. You can ask it to return things in a table. You can ask it to return things as audio. You can ask, hey, generate a video to do this, whatever, right? Google is much less personal because they're staying in the different modalities that their tools are already in. You are in Gmail. You're typing in email. Gemini will help you craft more text for that email or better text or whatever. They did show off some special things like their Notebook LM. I thought that was a really cool demo actually, where they synthesized a podcast with 2 speakers talking about like gravity and Galileo and whatever. And then like you could call in and have a dialogue with these 2 AI podcast hosts that was personalized to you. Give me a basketball example of kinematics, stuff like that. So that was really novel, but that I think for Google was more of an exception than the rule, right? Like besides that, everything else was pretty much, here's a way to make a really well-formatted Google Sheet faster. Here's a way to make a great email faster. Here's a way to plan a vacation faster. There was fundamentally nothing new about Google's presentation. It was just, hey, we're taking all of our tools, we're infusing it with Gemini. We have Gemini 1.5 Pro, we have Gemini 1.5 Flash, blah, 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 blah. But fundamentally, what you're getting is better Google, right? I think that's an actually very different ball game than what OpenAI is trying to do.
What I think is that Google is actually just looking at Microsoft, and Microsoft does the same thing up to now with OpenAI is Microsoft, of course, in a way, but it's like Microsoft does the same thing, like productivity things in its own software, and Google tries to compete there and not against OpenAI.
Yeah, so I think I agree with that. The difference is when Microsoft puts a GPT agent in Microsoft Excel, you get 2 things, right? You get like this little buddy that can do all of the advanced things in Excel you don't know how to do, right? Pivot tables, blah, blah, blah. There's all sorts of advanced functions in Excel. The other thing you get is a little buddy that keeps you in Excel in the first place. So when you have a question, instead of going to Google, you now just ask the buddy and he answers it without any context interruption. When you look at that, Microsoft doing that is really disrupting Google because they're saying, hey, you're not going to need to leave Microsoft's apps anymore to ask questions about how to use them. You're going to stay in Microsoft's ecosystem, whether that means a Windows level Copilot or an Excel level Copilot or a Azure AI Copilot, whatever, right? But you're not going to go out to Google, see a bunch of ads as part of that answer, come back and then figure out where you were and then like put your answer in there, right? When Google does that, they have a big problem, right? So search is their monopoly to lose. And I don't think any one company, not Microsoft, not OpenAI, not Meta Platforms, is going to take Google's search monopoly, right? What I think is going to happen is search is going to become a much smaller market because there are all these different use cases where you just want the answer. You know, like I'm not trying to do the research. I'm trying to come to some conclusion. I'm trying to answer some fact. So for all of those use cases, how do I do a pivot table? What's the oldest building in Greece? Blah, 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 right? I don't want 10 blue links. I want the one sentence answer. I don't want ads. I want the one sentence answer. You know, like I want to go about my day. So I think answer engines, which is where OpenAI is really going with this, right? Hey, there's this thing you want, and I'm going to either take an action or return a response that gets you closer to the thing you want. That is going to replace the search market. It's not that we need to figure out who the new best player in search is, and it may not be Google. It's that search as an idea is going to get smaller and smaller and get replaced with questions and answers.
And is there a way out for Google, do you think?
I do think so. I think the question for Google, right? It's like the classic innovator's dilemma is, do we keep making our existing products and services better and better? Or do we sort of make a bet on what the future is? And if it's fundamentally different from ours, we cannibalize our existing business to grab that new market. I think Google, if I was them, there was one of two ways to do it. And I do think they chose one of the two correct paths, right? The first is what they did, which is combine Google's AI research team and DeepMind and just do incredibly hard stuff in AI, right? So search is one thing, but they just released AlphaFold 3, which is a protein folding, great stuff in biologics, basically. And they have decided not to open source those models. They're opening some of the results. They currently have a huge edge when it comes to like bio and pharma and generating and discovering new drugs that it looks like they're holding on to. They're not just releasing it like they did previous AlphaFold versions. They're keeping it and they might be doing something with that. So we could see Google pivot into really hard areas of AI where they do have a huge natural advantage because of DeepMind, AlphaFold being one example, and trying to keep their search monopoly for as long as they can and just making it harder and harder to replace, right? The better and more AI filled search gets, the more different AI answer engines and personal assistants need to be before people are like, Google's just not good enough. I'm switching to this other thing, right? So that's one way. The other way could have been, hey, we own Android. We own handsets. We make the Google Pixel. We own the operating system. We own the App Store. We're basically Apple that's not Apple, right? We are going to come out with our own personal assistant device like the Rabbit R1, the Humane AI pin, whatever, but we're going to keep it on smartphones and Android will become that personal assistant for you. Everyone already carries this computer around. You know, they have their smart watch, smart headphones, their smart glasses, whatever. We're going to develop our own ecosystem focused on personal assistants, right? So I could have seen them go that way. I hope they end up doing more stuff with Android. They talked about it a little bit at Google I/O, but basically just, you know, a layer on top of their existing sort of operating system. I was hoping either Apple or Google would go hard and say, hey, we're going to build the Rabbit R1 version of this thing right into our phones, and you'll be able to turn off apps completely. And under the hood, the AI will download apps, manage them, keep them up to date, and interact with them on your behalf. You won't need to know the mechanics anymore. You say, order me an Uber and buy me a pizza. It opens the right apps. It configures a thing. It shows you an itinerary. You approve it, you deny it, you change it. But fundamentally, it's the assistant in your pocket. And we haven't really seen that from Apple or Google yet. So I think that's the path that would put them in direct competition with OpenAI. And until they do that, that's why I think they're not in direct competition with OpenAI, even though we're all talking about large language models, generative AI, and stuff like that. So
very, very, very interesting. Okay, let's jump to another one of your favorite subjects, Nvidia, powering this whole revolution. Yeah. Just like I have been, you have been bullish on Nvidia for a very long time, especially when it was down so much and everybody else thought it would die, more or less.
Yeah.
Tell me about it.
So I started buying Nvidia stock in 2016. I bought Nvidia for very different reasons than I buy Nvidia stock today. So back then it was selling consumer GPUs, and the hot thing that people were using that for besides gaming and besides science was crypto mining. So it was basically one platform with all these different uses, robotics, AI, sure. But what was obvious to me back then is GPUs are fundamentally different than CPUs, and GPUs are the best general chip for AI, right? There are application specific chips that do it better, but they're much more niche. So the trade there was always how many different applications can you support on one platform versus how good are you at those applications, right? So I bought Nvidia stock because I was a nerd and I like gaming, and I was, no matter whether we were at home or at work, we were always using Nvidia's products. So even when I was at MIT and we were hardware accelerating some of our things for the radars, we were using Nvidia's Titan GPUs. So I was like, okay, I'm going to buy Nvidia stock. I also bought AMD stock just because they were really the only other GPU maker. Intel, they're barely starting to make GPUs now with their Intel Arc chips. It's a coin toss, right? So I ended up buying way more Nvidia just because that's what I knew. But for every dollar I spent on Nvidia, I spent something like 10 or 15 cents on AMD stock as well, right? Which worked out really well too. Then in 2021, 2022, when they crashed really hard, it was on the back of like the whole crypto mining scandal and all these other things. But what had happened is the A100 became like the de facto accelerator in data centers. And this is before generative AI, before ChatGPT, before people really cared about accelerators. But it's like, if you looked, they had like this super dominant market share that nobody was paying attention to. And then they started crashing, they started crashing, they started crashing. This is like 2022 now. And their H100s came out. They were on back order forever. That like they were absolutely supply limited. Everyone was talking about it. It was definitely, they had cornered the accelerator market. And the problem, if I remember right, was like nobody really cared about that market. You know, it was just like, okay, they're accelerating graphic side of game, cloud gaming, whatever. But when ChatGPT hit, who was the market leader? So because I was already so deep into Nvidia stock and like understanding it for a completely different reason, the missing piece was just, hey, ChatGPT, everybody wants this. Now this is AI. Oh, wait, it uses the same exact technology I've been learning about, researching, touching, and using since 2016. It was just like the killer app that finally came. It was a no-brainer for me. So like when everything was crashing, I was making video after video like, no, they're pivoting towards data centers. Give it time because the H100 is going to be part of this larger ecosystem. And, I'm just parroting what they're saying on earnings calls, presentations, keynotes, right? Like I'm not making anything up. It's just like I knew where to look, and I was hearing everything I thought I needed to hear. Everyone kept calling me an idiot. This is a dying company. Bitcoin is crashing, crypto mining, gaming, whatever. And I was like, I didn't know how else to explain, like, hey, GPUs are for much more than that. I came out with video after video explaining, hey, this is a generalized parallel computing platform. AI needs that type of computing. And, those videos got hundreds of thousands of views. So, like, I definitely made a little bit of a dent and helped people understand at least, like, the nuances between CPUs and GPUs, why GPUs matter more for AI, all these other things GPUs can do, even if AI is just a phase and it's going away. When Nvidia started rallying, basically what happened is everyone was Googling Nvidia stock and my videos would come up as the answer, right? And so that's how I got big on YouTube. My wallet and my view count rose at the same time. It was really interesting. So
yeah, let's continue that.
yeah.
One of the things that people who don't understand Nvidia always say is like, oh, but there will definitely be competition. And one of the things that I say is that they have a lead, and I'm very, very careful here, of like 7 to 10 years at least, that I see before someone could disrupt them completely.
Yeah.
Could you explain why?
There's sort of two parts for that. First of all, Nvidia will never get disrupted on GPUs. They have an insurmountable lead, just like Google has with search, right? Like this is an apples to apples comparison. What is going to happen to disrupt Nvidia is computing will move away from GPUs towards other types of chips. For example, Grok is a private startup. I mean, they're not really a startup anymore, but a private company, that's focusing on a chip that's going to take the inference market away from Nvidia. And their chip doesn't really look like Nvidia's GPUs, right? So just like search belongs to Google. And the question isn't who will dominate Google in search. It's, hey, when search changes to answers, what happens to Google? When parallel computing moves away from GPUs to this other thing, what happens to Nvidia? That's the question, right? The reason they have this insurmountable lead in parallel computing is because they don't just make GPUs. This is like a critical mistake that people who are on the outside, not really doing the digging, don't realize. They say, oh, there's Nvidia and there's AMD, and that's how it was, and that's how it always will be, right? And that was right for a long time, because for a long time, they both just made GPUs. And actually, AMD started with CPUs, right? AMD actually bought Radeon. I think they bought a company called ATI that makes their Radeon GPUs. So AMD did that through an acquisition. They really make their Ryzen CPUs, their EPYC CPUs for data centers, right? That's their bread and butter. Nvidia has always made GPUs. Their first product was a graphics card. You know what I mean? It was a parallel computing chip, fundamentally different. Today, Nvidia really makes AI infrastructure. They make AI computers. And what those look like today is rack level supercomputers that combine GPUs, CPUs. So Nvidia makes a CPU called Grace, networking technology. So Nvidia makes Bluefield DPUs, data processing units. They bought a company called Mellanox that makes those. They make fiber optic called InfiniBand. They make Ethernet versions of that. They make, like the list goes on and on of all these other things that are not just GPUs that they make. And the point is to make an end-to-end system that's optimized for AI processing. You can have the best GPU in the world, but if your network doesn't have enough bandwidth to run them all, that's your bottleneck. Your GPU will never reach peak performance because it can't transmit and receive information fast enough. Just as an example, if the CPU that it's tied to doesn't send it instructions as fast as it can or as fast as it needs to, your GPU is going to sit there being unused, right? So what NVIDIA realized really quickly, in my opinion, given that this transition is only a couple of years ago, right? When they transitioned from high-end gaming GPUs to data center AI, everything, right? What they really realized is, hey, the answer is to optimize the total system and minimize the total operating costs, right? The TCO. What NVIDIA does that AMD doesn't do is they put all those systems together and they make sure that the total system is as cheap to run as possible, which means the most compute per dollar and the most compute per watt, right? So it's very energy efficient, very dollar efficient, very heat efficient. So it's expensive, but it's much cheaper than what it replaces, right? So when people are like, oh, NVIDIA is price gouging, what people don't realize is you're taking an entire data center and you're replacing it with one rack, which lets you do one of two things: reduce your total cost of operations from that entire data center down to one rack, or fill your data center with these racks and get way more computation for the same power budget and dollar budget, right? So I do think that they have this insurmountable lead. Hopefully that answered both questions, right? Like what they do is fundamentally different from AMD and why their lead is so insurmountable and why their approach is so different from their competitors, if they have any. Does that make sense?
Yeah, definitely.
Okay.
100%. And the software, and how far does that play a role, do you think?
I'd say that plays more of a role right now, kind of like how Apple versus Android, right? I believe the Apple language is called Swift. I'm not an app developer by any means. So NVIDIA has something called CUDA. It's basically a software development kit for GPUs, right? And so the only devices that support CUDA right now at scale are NVIDIA's, right? CUDA is NVIDIA's language, so they run it and it runs on their ecosystem. Why is that important? Because if they have a huge market share in servers, then you want to be writing in a language where you can distribute on the most GPUs, right? So their lead really comes from the fact that they have so many people using their hardware, so many developers developing on their hardware. And so CUDA is an ecosystem that just has a lot of support, a lot of adoption, a lot of power behind it. They're starting to monetize it now. So, I mean, they've always monetized it, but definitely their highest margin and biggest revenue generators have been their hardware solutions, right? But what's happening now is they recently released something called NIMS, NVIDIA Inference Microservices, NIMS, right? And NIMS has an interesting price structure. It's $1 per GPU per hour, or $4,500 per GPU per year. And what these NIMs do is it's like if you've ever had forget what it's called, but like the Nvidia GeForce Manager on your desktop, where it's like, oh, you're playing this game, let's switch to this driver which is optimized for this game. You know, you're just browsing on YouTube and you're watching videos, it's a different driver. So you have this little piece of software that optimizes the hardware based on what you're actually doing in real time, right? NIMS is kind of like that, but for data centers. It will keep track of, oh, hey, you're trying to use this service. I'm going to make sure that all of the libraries that it relies on are up to date. I'm going to make sure that if it's a graphic service, that the drivers are up to date. I'm going to download and manage packages. I'm going to talk to my neighbors to make sure I'm optimizing loads, blah, 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 blah. It's like it's doing all this stuff so that developers don't have to do it. Does that make sense?
Oh,
NVIDIA
yeah.
has taken this burden off of developers. You just put your code in this container. The container sits around it and makes sure that everything's up to date and all of its dependencies are in check and whatever. And now developers can just write code and say, hey, these are the things that my code depends on, right?
Yep.
So I do think that NVIDIA is moving up the chain. I don't know that NVIDIA will ever be like a true software company. Like we're not about to see Microsoft Excel like NVIDIA's version or whatever. I think what NVIDIA has done really well and the culture that they've built and that we always hear Jensen talk about is NVIDIA tries to do things that no other company can do. And when people hear that, they go, oh, he's just talking his own book. He's full of himself. But what I think he's really saying is when they attack problems, it's because they're in a position to own the entire market. They don't want to compete. They're actually not good at competing. So what they do is they understand, they create their own markets, and then they just fill it, they fulfill all the needs there. So just like NVIDIA was making GPUs and AMD was making GPUs, and then NVIDIA switched to making these total holistic systems for data centers, I think they'll find a few of those markets in different pieces of software as well, robotics models, maintaining code that sits on GPUs, whatever, and they will just dominate that market. No one will be able to touch them because they have this deep infrastructure and this deep, software, middleware and hardware layer that people just can't compete with. It's like trying to build an iPhone to directly compete with Apple. You know what I mean? It's like you're just not going to be able to do it.
Correct. I think that the whole system also makes the switching costs so extremely high that people
Yeah,
underestimate that.
I agree completely. And the truth is, data centers are really interesting and it's probably worth talking about for at least a couple minutes, right? So when we think about switching costs, people typically think of I'm switching from Android to iPhone. I'm switching from gas-powered vehicles to electric, right? I'm switching from PC to Linux or whatever, right? Data centers don't switch. Data centers are large portfolios of hardware and infrastructure and software because they have a portfolio of different use cases and workloads and things like that, right? They offer different services. Like if you look at AWS, it actually offers like several thousand cloud services that people mix and match and rely on to build businesses on top of, right? So it's not that Amazon Web Services will switch from AMD to NVIDIA and back. What happens is their portfolio mix will change over time as their workload demand and their customers and their install base has new needs, right? Like if there's a really great new AI model that everyone wants to use as a customer support bot, they're going to pick the best hardware that runs that support bot. What does best mean in this case? It means the lowest cost to Amazon Web Services. So they're going to have to decide, does that mean we go all in on another like giant GPU cluster of NVIDIA's stuff? Or do we patch some stuff together based on what we already have and how we already serve this workload and whatever? And that is kind of a black box, right? It really just depends on their latest infrastructure projects, what they forecast is the demand for the next big thing, what else is coming out, right? What chips they're currently building. So Amazon, Google, and Microsoft all build their own chips, right? Like, Google just launched I think it was like the 6th version of their TPU. And we saw Microsoft recently release like Cobalt and Maya and like all these other things. And at Microsoft Build, I'm sure they're going to talk about another chip, right? My point is, these are portfolios of technologies. So you're not really talking about switching costs. You're really talking about when they expand that portfolio in the future, how does that shift AMD's versus Intel's market share versus Google's proprietary chips eating some of that market and making it smaller, so on and so forth, right? So I hope that investors find a lot of value in that because it's not and that's really important to understand because otherwise you'd be forced to choose NVIDIA or AMD stock, right? But it's not a zero-sum game because these data centers are constantly growing.
I have both as well. So, and talking about Intel, how do you see it? Because, you know, they are desperately, I would almost say, trying to catch up. Do
Yeah.
you think they will succeed?
I'm thinking that less and less, and it's not because they're not capable. So if Intel went all in on AI, I bet they would be a great player. The problem with Intel was, is, and will always will be, unless something fundamentally changes, they're fighting a war on like 4 fronts, right? So their foundry business has a lot of catching up to do, and they're doing a great job. But, 5 nodes in 4 years, they're definitely doing an excellent job, but that's just one piece of their puzzle, right? If their foundry business tanks again, they're dead because they make their own chips, as opposed to TSMC, who makes Nvidias and AMDs and all that. And TSMC just focuses on making chips, while Nvidia just focuses on designing those chips, right? So you get this benefit of having 2 brains working on 2 problems instead of 1. That's one problem. And obviously these AI chips require these most advanced nodes, right? 3 nanometer, 2 nanometer, 1.8. The second problem is Intel is the founder of x86 and the world is moving towards ARM, right? So like on the CPU side of things, as edge devices and ARM chips get better and better, we need x86 less and less. We're starting to see ARM server chips. You know what I mean? We're starting to see, for example, NVIDIA's Grace CPU is an ARM-based chip. So, okay, Intel's foundry business is one issue. Intel's CPU business is another issue. And then how they want to get into GPUs is a whole nother issue, right? So they have Intel Arc GPUs, right? Which I think have been a pretty big miss so far. They haven't really successfully captured much of the market. I know that Arc is in certain laptops and it's actually a really great graphics processor. I just got the Asus ZenBook Duo 2024, that 2-screen laptop. It uses an Intel Arc GPU. Very happy with it. But then they have their Gaudi 3 chip, which is their data center AI inference chip, right? It's their AI accelerator. And the question is, why would anybody want this AI accelerator over AMD's chips or whatever? But nobody is like the thing that I think everyone agrees with is Gaudi does not really compete with Nvidia, right? Gaudi 3 came out and they benchmarked it against the H100. The H200, I think the first one just got delivered to OpenAI a few months ago now. And then Blackwell obviously got announced at NVIDIA GTC. And like Gaudi and Blackwell, I mean, you might as well be comparing Teslas to the horse and buggy, right? It's like these are just completely different pieces of technology. So I think Intel's big problem is they're doing a lot of things and they're not the best at any of them. They're sort of this general all-rounder. Yeah, we make chips, but not as good as TSMC. Yeah, we make CPUs, but it's not the architecture of the future, and it's not as good as AMD or some of these proprietary chips coming out of the cloud centers. Yeah, we make these AI accelerators, but they're not as good as NVIDIA's. They're not as good as AMD's. So I think Intel is sort of that. I hate to use the term like scraping the bottom of the barrel. I do feel like Intel is always, hey, if we can't get that first thing, we'll just use Intel's. And I don't know how they fix that. I really think that this is a company, and it's so important to have them because so much of the supply chain runs through Taiwan and China, right? So of course you want to bet on an American semiconductor company. Like I think it's great that Intel makes chips. I wonder if the answer is something like Intel needs to spin out a separate foundry business and just have 2 businesses with 2 CEOs, 2 sets of leadership, one that focuses on making chips for Intel as the primary customer and for other companies, and one that focuses on designing chips that uses Intel foundries when it can, uses TSMC whenever it needs to, whatever. But like, I think doing that would be a big win for everyone. But is it an impossible ask? Maybe. That's so steep into their culture, building their own chips. How do you separate that out?
Actually, suppose it happens. Suppose they split up and gun to your head, you have to invest in one of the 2 businesses. Which one do you invest in?
I would invest in the foundry business.
Me too.
Yeah,
Me
yeah.
too.
I wouldn't touch the chip design business anymore. I would invest in the foundry business.
Yeah, because I think that if they would really specialize there, they could compete with TSMC, and they're actually moving quite fast there in the foundry as well. Recently, they have bought the newest EUV machines from ESML and before TSMC, I would definitely bet on the foundry as well. So yeah, maybe they should do that, right?
I think the beginning of the end of them, or at least this current phase for them, was when they had to cut. So Intel stock was famous for its like almost 6% dividend. It was crazy. It was like 5.5% or something. And when they had to slash that to like 1.5%, you ran out of reasons to hold the stock. That was like the thing keeping it in the market. So I think they need to do something really, really dramatic to sort of get an edge in one of these. It's really like 10 markets, one of these two markets being, building hardware or designing it. But really, it's a tall order. Like I definitely wouldn't want to be Pat Gelsinger right now.
No.
I
want to move to something else that you're
sure.
extremely good at. And there, I don't know that much about it, especially not compared to you. And that's Palantir. Yeah, I already see the laugh on your face. I'm a huge admirer of Peter Thiel and I read
Sure.
0 to 1. I read The Founders, by the way, great book about the PayPal history. And at the same time, to me, Palantir is too much of a black box. Probably I don't understand. I know what they do, but I don't know what makes them better or so. Educate me.
It's really interesting because this is another example of those, like, it's not better, it's different. And because it's different, it solves problems that can't get solved in any other way, right? So like the big theme of all the companies I try to invest in is exactly what we're talking about now, which is you've developed some sort of novel approach to solve a market problem. And so you own 100% of that market, right? So when people compare, let's just like back up and like talk about investing in Palantir. When people compare it to something like Snowflake, it's a faulty comparison because Snowflake doesn't claim to do the things that Palantir does. It's not building ontologies. It's not fighting terrorists, right? Like it's just this weird, like, hey, they're both SaaS companies, they're both like, they have some similar metrics. So let's just comp A versus B. So let's talk about, I guess, like what Palantir does, like from first principles, because maybe this will help people really like digest the differences. There's something called pattern of life. This is like, I think if I had to describe Palantir from scratch and nobody had any idea, like, okay, explain it to me for the first time, I would start here. What AI is really good at and what Palantir's AI, the type of AI that I worked on at MIT, and why I have like the head to understand Palantir is because what Palantir does is build a model for a pattern of life. Palantir started at PayPal by being like a fraud detection system. Before it became Palantir, it was part of PayPal's fraud detection system. What does detecting fraud mean? Detecting fraud means you understand, based on a lot of data and a lot of transactions, what a normal financial transaction looks like. Somebody checks something out on a cart, they get an item, they get a bill, it's an invoice, whatever, right? Normal financial transactions. And you get many, many billions of those as a corpus of training data. Every once in a while, you're going to get a financial transaction that looks different than the others. The money is routed back to the sender account. The checkout price somehow doesn't match the cart price. Whatever it is, you're detecting an anomaly. And the reason you're detecting that anomaly is because you've built up with a very high degree of confidence, the normal pattern of life, and this thing falls outside the statistical bounds for that pattern, right? Does that make sense so far?
Oh, yeah,
really,
sure.
really confident this is what a normal transaction looks like. So when I see one that doesn't look like that, I'm really, really confident I should go figure out why it looks so different. It's an anomaly.
You're telling already something I didn't know, that they actually took PayPal's system.
Let me back up. I'm not saying it's PayPal's like direct system, but the idea came from PayPal's fraud detection system, right? Like,
and also because in 0 to 1, Peter Thiel writes about this, that he sees the future as human and computer working together, because the detection system sees something which is different, and then a specialist looks, is this really different?
Absolutely. And going back to everything we just talked about before Palantir, right? Again, that's why these AI agents are so important. What are they going to do? They're going to tell us, hey, you don't need to worry about this thing you do every day. I'm going to automate that. And then what I'll do is I'll flag you when there's something special, an anomaly I need your intervention for, because you're my boss. I'm the AI, you're the human. You're going to tell me, right? Like, I'm going to read all your email and I'll tell you when there's one that, hey, I have no idea how to respond to this. That'll get kicked to you. So now your inbox might have 10,000 emails, but 10 make it to you and the other 99,000 whatever are just handled, right? Okay. Yep. Anomalous financial transactions, right? Pattern of life. I know it's normal, which means when I detect an anomaly, I know I need to go look into it. Let's talk about the border, right? Like, there's a normal pattern for how people cross borders, right? There's a normal pattern for troop movements. There's a normal pattern for satellites in the sky. There's a normal pattern for traffic. So if I can build this pattern of life in whatever the problem is, how viruses spread, again, how people cross borders, whatever, then when something is different in that pattern, I can reliably detect an anomaly and bring it to your attention, right? No matter what the field. That's like the big twist on Palantir. Is the first thing they do is they ingest a lot of data. They don't keep it, but what they do is they build a pattern of life. That pattern of life is called an ontology. That ontology is here's the pattern of life for your business. Here's where your assets go. Here's your logistics chain. Here's how all these things fit together. Here's who manages them. Here's who's responsible for them. Here's who finances them, right? It's all the things and their relationships, going back to financial modeling, right? It would be like, here are all the websites connected to this financial backend with their checkout buttons. Here's who's interacting with what. Here's all the purchase orders, right? It's a network of things and their relationships. Okay, that's the ontology. So the first way that Palantir is different is it helps these enterprises build up that pattern of life for themselves so that they can get one clear picture of everything in their enterprise, right? Gotham does that for government enterprises. Foundry does that for commercial enterprises. Apollo is a completely separate animal. It's all about like distributing and managing software. So like going back to our discussion about Nvidia NIMs, Apollo probably is more analogous to that than what we're talking about here. And then the Palantir AIP, their artificial intelligence platform, is again now what we're talking about when we're talking about OpenAI, ChatGPT, Google Gemini, right? AIP is a layer that sits on top of Gotham, Foundry, whatever, and now adds, this large language model capability. So instead of interfacing with the ontology, which I'll get back to in a second, you can like talk to a chatbot and be like, hey, help me find this, help me understand that. And AIP is like, well, I'm going to go look at your ontology, do this really complicated stuff, but then return it in a way that you can understand, right? Here's a plot. Here's what you're looking at, right? Okay. That ontology is the thing that makes Palantir special. So if you go watch their YouTube channels, if you go watch their AIP, boot camp stuff, whatever they release anywhere, they're always talking about this ontology, this ability to help enterprises understand the patterns of life of their resources in real time, right? So how they're interacting, who's doing what, blah, blah, blah. Resources being industrial assets, but also personnel, data, right? Like it's all that stuff, right? So these ontologies get pretty big and pretty complicated pretty fast, which is Palantir's strength. Do you have any questions? Should we be discussing that? What do you want to?
I totally understand it, actually. So they have the government side, they have the
Yep.
private side.
Yep.
Am I right if I say that the government side is still bigger than the private one, or
It
has
is
it
still
already
bigger.
changed?
It is still bigger by revenue.
Mhm.
Based on their last quarterly earnings, I think this is the last time we'll say that. If they keep growing at their current rates, I believe next quarter will be the first time their commercial revenue is slightly bigger than their government revenue
Mhm.
for the first time in their history.
So what the projects that they sign are huge, right? So
Yeah.
both for the government and private, right?
Yes, there's like some caveat to that, right? So
Mhm.
yes, in general, but they do have small projects on the commercial side, and they might on the government side. I honestly don't pay too much attention. They help startups by literally giving them Foundry, letting them build on top of Foundry, and then like they work with those startups over time, right? So I know they are capable of supporting smaller businesses. I think to grow their revenue right now, they're attacking bigger and bigger contracts, but their overall plan is to eventually move down market from enterprise to small and medium-sized businesses, right? So
Yeah.
just throwing that caveat out there, but in general,
That's very, very interesting information, because up to now I thought they only, catered to the really big enterprises, and
no, they definitely have a whole section called Foundry for Builders that is about much smaller, like Lilium, if you've heard of them, the
Yep.
eVTOL. Yeah, so Lilium, I believe, is on Palantir. Like they're
Mhm.
one of Palantir's clients.
So what does a typical project for a private company look like?
For Palantir,
Yeah.
this is me guessing, right? So just to be
Mhm.
clear, I've no like special knowledge about this stuff.
Oh, you do. You do, because not only do you study a lot, you follow the course in Palantir, right?
Oh yeah, so I had access to Foundry for a while. Like I got to
Yeah.
play with their software, which was pretty special. I just mean like I don't have any inner knowledge of their
Yeah,
like
sure.
their business dealings, right? I don't know anything that isn't publicly available. So I just want to make
Mhm.
that clear. What that probably looks like today is actually pretty different from how it looked even when I was using Palantir's technologies. So they have these things right now called AIP boot camps. And what AIP boot camps are a way for enterprises, whether they already work with Palantir or they're deciding to, or they just want to see what's up, to come in and work with Palantir staff to build real use cases for their businesses. So they bring their data, they pipe it in, even if it's sensitive, because Palantir doesn't hold that data, whatever, and they walk out with real pieces of software and use cases that they can go deploy at home if they decide to buy Foundry or Gotham or whatever the appropriate platform is, right? That ramp up period is a lot smaller thanks to AIP than it was when I was using Foundry. I didn't have AIP. I was banging on a keyboard with my physical fingers, learning a little bit about the code, learning a little bit about the platform, having to piece it together. I had a very tiny use case, definitely compared to their normal sized clients. So for me, it was a couple months of ramp up as we got the data ingested, hand built our ontology, labeled all the different pieces of data that we cared about, built dashboards, built little boxes that like little computation nodes that would say, okay, every time you see the stock data, build a rolling average or a model or whatever, all these different modules, stitched them together and then ran data through the resulting ontology. Today, my guess is Palantir has a lot more automation and tools to do that on the fly, right? Hey, you ingest your data, and then Palantir will figure out that structure as it gets that data, the relationships. Of course, there's always going to be some stuff being done by hand by software engineers, but a large component of it is probably automated because they're always talking about Foundry for finance, Foundry for robotics. They have all these different Foundries, versions of Foundry. These are not all separate products. They're baked in modules, services, and pieces of code that they've already built use cases for. So you get them out of the box, right? So moving away from a software engineer doing custom code to being able to deploy something that works right out of the box for that kind of business. For example, detecting anomalies in large amounts of financial data or data about border crossings or everything else we just talked about, right?
The traffic around a certain compound in Pakistan with
Totally.
with a certain Osama bin Laden.
Totally. And so the big unlock here for people who are interested in understanding Palantir is understanding that everything we just described, from hunting down Osama bin Laden to detecting financial fraud in a large corpus of transaction data, it's actually the same thing. It's not exactly the same thing, but in both cases, you're developing a pattern of life, a large model of how things normally look like. And then your priority is finding and analyzing anomalies, whether that's an anomalous financial transaction, an anomalous border crossing, whatever, right? So, and based on like the actual nature of the specific data you're talking about, robot motors, financial data, human bodies crossing borders, whatever, of course, some of the other tools and modules and models need to change, right? How a person moves and how money moves, that's actually two different forms of movement. So the models for that need to be different. But it all goes back to the same central idea of building an ontology and then building tools on top of that ontology to analyze it. And now building this AI platform on top of that so that it's easier for you to interact with those tools and the ontology underneath it. That's what Palantir does.
Great explanation. Do you think they will, take this a step further even? And this is in a form, it's defensive, right? Trying to sort out the things that should not be there. But it could also be used in a generative way. Do you think they will take that step in the future?
So they actually do already do that. So,
Mm.
I was just trying to simplify and like sort of clarify like the foundational purpose of an ontology, right? But both Gotham and Foundry can actually hook into those assets and you can actually control, task, whatever those assets from Foundry. So for example, if you're a large logistics company with a fleet of trucks, you know where all those trucks are going by using Palantir Foundry, right? Oh, truck 2 is on this road, truck 8 is on that road. You can, in Foundry, retask that truck. So whatever piece of software you use to actually manage that fleet, Palantir Foundry can probably connect into it and say, hey, I'm going to change the destination for that truck. It talks to that software. The software talks back to the trucker and say, hey, you have a new destination. This order just came in. But it was really some guy sitting at Palantir Foundry to do that. So going back to the ontology thing, now it's like a really complex system, right? It's not just about understanding an existing pattern of life. It's about manipulating that pattern in real time. Hey, I need to change this route. Hey, I need to reroute that financial transaction, whatever. So Palantir Foundry, and I'm sure Gotham, is absolutely capable of doing that too.
Some people are afraid of the power of Palantir. How do you think about that?
I don't really understand the whole fear versus excitement. Like, I don't really have emotion when it comes to like the capabilities of Palantir software, right? Palantir builds tools, just like a hammer is a tool, just like a firearm is a tool, right? Like Palantir Foundry is just a tool. It can be used for good purposes. It can be used for nefarious purposes. And just like any tool maker, you hope that Palantir builds in safeguards to make sure that the nefarious use cases are limited and the good use cases and the righteous use cases are not limited, right? I'm not afraid of Palantir. I don't know why anyone's like, what you should be, if you care about that kind of stuff, is you should make sure you're advocating and lobbying Palantir to not misuse the power they've built, right? Like, that makes sense. I don't want anyone to misuse any AI for any reason, but am I afraid that they're gonna? No. Is somebody going to? It's inevitable, right? Just like any other tool can be misused, used for a completely different purpose than intended, used to cause harm, so too can Palantir, right? Like,
sure. And probably Palantir itself will be the best defense.
I would hope so, and not just Palantir, but one of the things that Palantir really focuses on is building a community of users and vendors that deeply understand their platforms. So for example, Palantir runs these AIP boot camps, but other companies can get certified and run these boot camps as well. If they have the specialized use cases that they deeply understand, they can show other companies how to do that. A healthcare company that's using Palantir for managing a hospital, let's say, right? You can imagine you would much rather go to hospital administrator boot camp run by a hospital than by Palantir proper, because they're like, no. This is like, we understand the language of hospitals and we understand how to use Palantir, right? So I do think that we will see those safeguards come from Palantir for sure, but also from other companies that kind of take ownership of their slice of Foundry for their specific use cases built into these AIP boot camps.
All right, that's very valuable. We're going to round it off more or less, but I have one more question for you, and that's about the future. How do you see the future evolving? And you can go wild here. I mean, you can talk about the next 3 years, next 5 years, next 10 years, whatever you want. What trends do you see that maybe people don't think of could become a reality?
Yeah. So if you would have asked me this last week, I would have had a very different answer. But post Google I/O, post OpenAI Spring Update, and I think, Microsoft build this next week, here's what I think is becoming increasingly clear. AI is going to be something separate from us. We're not going to use it as like, it's not going to get like baked into us, sort of how Elon Musk envisions it with Neuralink. It's going to be this separate like AI agent that's not just an extension of yourself. It is like its own thing. I think what that means is wearables are about to look very different. My sneaking suspicion is things like the Rabbit R1 and the Humane AI pin will actually probably die. I think what's going to happen is everyone's going to keep carrying a smartphone. It's going to get extended by a smart watch with a camera, smart earbuds, smart glasses, I can believe are a thing, like the Meta Ray-Ban glasses, right? And what all those things will do is feed an AI model that works to assist you, right? Hey, I noticed your heart rate is a little elevated. Do you want me to play some like de-stressing music? Do you want me to put on your favorite podcast? Hey, I noticed you're drifting while you're driving. Do you want me to play some rock and roll or whatever? You know what I mean? It'll be these weird, what we think of as really advanced multimodal things that we do. Crank up your radio and put on rock because you're falling asleep behind the wheel. The AI agent will understand how to do that for you. So I think smart glasses, my sneaking suspicion is we're about to see smart glasses become the next big thing that'll interface with your phone to deliver like this AI hands-free experience. When you're shopping, it'll help identify items. oh, you're thinking about buying this? Hey, I just found it on Amazon for $50 cheaper. Do you want me to order it before you put this item back on the shelf? You know, things like that, I think, are going to become very mainstream much faster than we realize. Like, have you ever used Honey, the Chrome extension? I bet Honey is going to be one of those things that gets baked into Meta Ray-Ban glasses. And when everyone goes shopping personally, they start getting guaranteed the best price. And price matching will be a weird artifact that makes a comeback because everyone's going to have this AI agent that says, hey, I found it for $50 cheaper. So what are stores going to do? They're going to say, hey, buy it from us at that price instead of like putting it back on the shelf. We'll price match, right? Like, so there are all these like weird things that come out of it if you think deep enough. I don't think people are picking up yet. And my guess is that's less than 3 years away. We're all wearing either a pendant or smart glasses. You know, if you wear prescription glasses, you'll wear glasses. If not, maybe it's a pendant or like a watch that you point, you know, like I'm not sure what the form factor is going to be, but it's going to work directly with an AI agent to take in audio, video, text data. It's going to understand the emotions on your face. It's going to understand, you know, if you're wearing a smart watch, it'll tell if you have an elevated heart rate or if you're stressed or your blood pressure is high or whatever. And it'll use all that information to start making decisions that you didn't realize you were making at the cost of energy, right? So what it's going to do for you is offload a lot of those things that you stress out thinking about, falling asleep behind the wheel, getting the best price at a store, right? Like, and AI will help you do that. And that's the mark of a really good personal assistant, right? Someone standing right next to you and saying, I'm trying to help you do the thing you're doing right now. So, and I bet that becomes pretty cheap, pretty commoditized. And then there will be this new thing that somebody comes out with that I don't know what it is yet, that will sit on top of that somehow to be a differentiator, right? Like, and now that just depends on where AI is in 3 years. So that's my guess.
Well, it makes me think. I read this today, actually, this morning. I'm a road cycle fan, and Mathieu van der Poel, he's the world champion. He has a special watch, and it's not a whoosh or something. It's American.
Okay.
And you know, he doesn't eat red meat before races because his watch told him that he doesn't digest it very well.
Exactly.
That's what's going to happen probably then. And then maybe just sneak in one more question. What do you think will change for you as a YouTuber with AI?
So one of my big worries is that AI is starting to sound and look so good that somebody will come out with an AI YouTuber that can just make videos 24/7, right? Comes out with 1 or 2 videos every hour that are very high quality, the right information, the right voice. You can't tell that it's not a real person. And that, like, you will just have an AI YouTuber at the top of every type of content, finance content, technology content, lifestyle content, because they can crank out high quality content much faster than somebody who's like going and filming and editing and uploading and doing thumbnails and titles and all this other stuff. I think there will be a time where, and it's probably not too far away, and it's probably using OpenAI stuff, right? Their video model, their audio model, you know, whatever, where somebody learns to dominate all media, not just YouTube, but like all media, because they can synthesize good, you know, what looks like a video, audio and video AI content much faster than people can currently create it manually by doing it for real, right? I think there's going to be a huge disruption. I think Google is, like YouTube is trying to force people to mark whether their content is AI generated. But the question is, how can you tell? So hopefully some of these watermarks, these AI watermarks, are good enough to like be detected and there are real detection systems in place. But I'm definitely concerned about AI videos starting to disrupt human content creators.
I'm pretty sure that your human factor is so good that you will not have to worry too hard.
We'll see. I appreciate that.
I mean, that still makes a difference. And thank you very much for this wonderful conversation, Alex. It was a pleasure talking to you, and I've learned a ton.
My pleasure. I'm happy to do it. Thanks for having me.
Thank you very much.
I hope you enjoyed this content. None of this is financial advice, so don't buy stocks only based on this information. Chris and the guests may have positions in the stocks they discuss. Get much more free and paid content at multibaggernuggets.com.